Okay, so we just talked about AFC, 6 gigahertz, Wi-Fi 7, a lot of things to offer in large public venues, and we have been doing large public venues for a while. I kind of got into large public venues when we started doing Cisco Lives, which, retrospect, was a good career move, but very challenging at the time. So we've learned a lot about these environments. You've got environmental considerations, AFC, indoors, outdoors. There's new regulatory. We've got to register hardware for one or the other. So there's a lot of challenges built in, even though we're getting a lot of advantages. Installation complexity. No stadium has ever been built the same. They're always architecturally impressive, and they have different lines of sight, and they have different sweeping venues. They don't build them to put Wi-Fi in them. Configuration and optimization, how do you tune it? Once you get all the APs in it, compatibility with client devices, we've got changing specifications. So there's definitely challenging environments out there in stadiums. One of the things we're doing right now is releasing the CW9179F. This is now the 4th generation antenna that we have built precisely for large public venues, stadiums, convention centers. It is the first Wi-Fi 7 one that gets everywhere. Part of the problem in stadiums is you're going to have long distances, and long distances is tough without hyperdirectionality. You get hyperdirectionality, then you've got to manage all of that. Going into this package, we've got Wi-Fi 7. It can get everywhere. We've designed it for every venue. We've taken a lot of things that we've learned about, geez, that was great for that antenna, but now what do we do for this one? Configurable and flexible installations, on-prem or cloud managed, so you don't even have to choose an architecture now. Real world examples. Well, we took it out and we started testing it. This is Bottle Rock. When was that?
2 weeks ago in Napa Valley.
2 weeks ago in Napa Valley, and they all had a wonderful internet experience. It was a great fan experience.
What we did is we hid it in plain view.
I know. I remember very well when I saw it show up on LinkedIn, and we were like, gosh, we're not releasing that until
we should have covered that, but we didn't. It's funny because we actually covered the 9104s, which was weird, but anyway.
Well, live and learn. A couple of interesting things. One.
This is a big one.
This is a big one. So for AFC, I've got to register my hardware as either indoor or outdoor. And that's a challenge if you don't want to have too many SKUs. The guys got together, this guy got together, they said, you know what, if it's going to be outdoor, it should be waterproof. And if it's going to be indoor, it doesn't need to be waterproof. What if we put a switch on that door? And we just made that 2 different APs.
You just way oversimplified what really happened.
I know that means
there's a great story behind this, though. Like Fred Anderson, we got to give Fred credit, because he's a pioneer in this world. I was frustrated with the rules, the low power indoor, the standard power, the labels, all these things. Mm-hmm. And then, you know, several IPAs later, a really good idea came out.
As it will.
And Fred, who lives in Florida, was drinking a Florida Man, by the way. Just to let you know. That's a really strong IPA. Mm. But it was a good idea. Oh, question.
I have a question about that door.
Yeah, sure.
So, in marine environments, if you've got something like that with just the screws, eventually the water will get in. So
yeah.
With enough pressure, you can get water in under there. Is there a gasket under there?
Yeah.
How do you?
Yes. Yes.
And I will tell you that. So we call it an environment pack, and so the AP itself ships indoor mode. So you'll get it like this.
Yeah. Okay.
Right.
If you want to do outdoor, you get this environment pack, which comes with all the gaskets and seals. And then even since that time...
Actually, we got to go forward, yeah.
Yeah. Even since that time, we've stiffened up that kind of door to make sure that it compresses those seals better. Because, you know, we go through our betas, we learn our things, and we're like, you know, that thing should really get in there a little better than it does.
So what I'm looking at in the picture, you've got the little slots for your cables coming out, and there's a...
That has silicone gasket.
Yeah, and there's actually multiple glands depending on your cable diameter.
Okay. Okay.
Right.
Alrighty.
Now, we went through this from an installer's point of view.
Everything.
What's that?
We went through this as installers.
Okay.
Yeah, there's actually some more coming up here. I'll show you that.
Yep.
Thought about on
but I mean,
the fly.
Like, this is probably one of the things I was the most happy about, because The idea of having something that you could deploy indoors, get the full 1200 megahertz, but then take the same product and go outdoors and have it standard power only and weatherize it is pretty key. And when we went through the original kind of thing, I think the FCC, you know, that's where we started, looked at us and kind of shook their head at us like, we're not sure what this is that you just did. But we marched forward with it. And then they came back later and they said, that's a really good idea. So we like it.
So you said there's a switch that signals standard?
There's a little BIOS chip. Yeah, exactly. So it's a little chip and it marries up to the AP and it basically, so that was part of the thing with the rules. You had to make sure that it couldn't be counterfeited, that somebody couldn't, you know?
Right.
So it's one of those things where like, hey.
So it's not just like a pressure switch.
No. It's an actual chip that authenticates itself to the AP.
Smarts there.
No, Sam, you're going to need to order that cover from me. That was part of the deal with the FCC.
Yeah, no, it was one of those things where early on, I felt like it was almost like Y2K, like people I don't know what's going to happen. So they didn't really give it a lot of time initially.
Yeah.
And then as things kept progressing, we just moved forward with it. We're like, we're going. Because literally this idea is over 2 years old.
Yeah.
And this is the first product that's utilizing it. So.
One of the other things, you mount these highly directional antennas and they have a very, very dark space behind them and under them because, well, that's on purpose. I think this was your idea.
Yeah, well, so again, through the history of high density Wi-Fi for us, if you recall, back on like a 3802P or a 9130, you could have a breakout or RPTNCs and a DART, but you had the ability to have two different antennas. And so when we sat down collectively to look at what we were going to do next, we called out the things that bothered us. And one of the things I was like, hey, I wish we could do that again. And then some really smart people said, what if we did this? And so we can basically switch the 5 gig low and the 2.4 to the back. And people are going to ask, like, why aren't you doing the 6 gig? Well, there's only one 6 gig radio, and we want that out the front to the masses. But the idea behind it is that anything that you're going to use on these small patch antennas that are coming out of the back, it's going to be a short throw.
It's going to be a backfill.
And it's probably going to be 5 gig only because not too many people are doing 2.4 anymore, but it's there if you want it. So,
is there integrated BLE, and would the BLE come out of the bottom ports?
The BLE would not come out of those ports.
Not come out of the ports, instead of go out the front.
Okay.
Right.
Okay.
But you couldn't get back there or in front of it without being detected.
Right.
Okay.
What happened?
Oh, I hit the wrong one. I did. Oh, here we go.
All right. So
this gives you a little better idea.
This is critical. So this is one of those things, if we're like just super honest, and we are, when we started going out and we had these early prototype units, I live in Tampa. I, of course, put them into the Live Nation Amphitheater in Tampa because it's close to my house. And I showed up when this pallet of APs arrived, and I was like, all right, we're going to put these things up there 100 feet up. And then we're like, because
seems like a lot to manage.
You got to think about, like, the cable is up there, right? So I'm relying on a guy who's not really a Wi-Fi guy to be on a lift that might be 100 to 150 feet up in the air to assemble this and put those glands in correctly and put that door on correctly. And that ended up being a bad idea. And we lost a couple, lost a couple to some water because, I mean, it's just reality, right? Like, it's hard to, you got to do it right. And you don't want to do it right. Like, so that's why we call it like off ladder installation. We're like, you don't want to be up in the air figuring this out. So we came up with this extender thing. I called it a, what did I call it? A dongle, but what did Nicholas call it?
Oh.
What did Nicholas call it? Quick Connect. Yes.
Quick Connect.
Techie.
There you go.
Quick Connect. So we're going to use that term. But basically the idea is that on the ground, in a safe place, you can put these doors on, you can properly seal the door, but then you're going to have this extension that comes out, this Quick Connect. That Quick Connect has this barrel connector where you can take an Ethernet cable and weatherize it. And it has some other, you know, it's one thing like if you're going to do it one time, but there's other customers out there that do this like kind of daily, like
every
think about
week.
Like concerts, think about like Josh and I are heading to the US Open on Thursday, and we have a bunch of these out there. Well, guess what? At the end of the Open, do you want to take that door off to get your AP back? No, you don't. So we came up with this idea. So if you order the environment pack, which is a separate part, we will ship you one of these.
Environment pack is $2,000 per AP.
No, I don't.
That would be the PM's job to get that price.
Talking to guys.
We're just here to tell you how awesome it is, Sam.
On that,
Okay.
Fair point. Good.
is that, obviously it looks like it's some sort of oddball connector. Is it industry standard of some sort?
Oh, it's actually a cable that's been used in the past that we slightly modified.
Okay.
Yeah.
But it's not like something that just got dreamed up last week. It was like, oh, we used to have this thing, and we just made it.
Because I'm assuming you can go somewhere and get the cables that connect to it in various lengths and whatnot, depending on what you're doing.
Or if you needed something different, you could. But the thing is you just need to get the actual, receiving end of that Ethernet connection outside of that door.
Right.
Yep.
That's the key. So.
All right. Performance comparison, overhead or under seat. Well, we've been big fans of line of sight for a long time. You can do it under seat. You're going to have more co-channel interference. If you do it under seat, what I don't like about it is I call it lumpy cell. It very fast as you expand away from that AP, you find different. I'm not calling you lumpy, Matt.
Okay. All right.
I called that. Are you okay today?
No.
Oh, sorry. Just checking.
Check.
But your performance degradation to distance goes way up when you have higher co-channel interference. You're putting more bodies in between you. Everything about non-line of sight just makes Wi-Fi harder. Does it still work? Yes, but the guy 3 seats back from me is having a very different experience than I am sitting on top of the AP. If we do line of sight, we get much more fidelity. We get a much more even distribution of the bandwidth in the cell. We get lower co-channel interference, which is why we get more distribution of performance. So we do believe that line of sight is probably the preferred way to go, and it's held up really, really well in some very high overrun conditions. Go ahead.
I was just going to quickly explain what you see here.
Yeah.
Fast.
There.
On the left-hand side, this is an underseat deployment. This is a Super Bowl. These are APs, that's time.
Yep.
When the building is empty, it is very contentious because they're all omnis on.
Oh, it's horrible.
They all hear each other.
Yep.
The radios are super busy. You put a bunch of water bags and other people in the way, and the best it ever operates is actually when it's full. So during a Super Bowl, you have more people than you've ever had in that building. You have extra press, you have all these things. So that's the best it's ever done. On the right side, that's a directional only deployment. So you can see that it's super quiet, like when it's empty, and then it heats up when there's something going on. And that's what we want. Over here, what you will see is like if you're going around with like a AirCheck G3 or one of NetAll, I think it is now, but you would see, and people had us chasing our tails at like non-Wi-Fi interferer. There was no non-Wi-Fi interferer. It was Wi-Fi from really far away that the device couldn't decode. So you're chasing your tail looking for this thing? No, it's Wi-Fi. So things like that were happening. So we just wanted to call that out. Where I really think you're going to end up is in hyperdirectional. If you're in, like, say, an arena, maybe 20,000 or less, you're probably going to be overhead everywhere. Maybe a little bit under seat. In the really big stadiums, you're going to be hybrid. You're going to be overhead everywhere you can be, under seat where you can't be. That's how we see it.
You just haven't lived till you start pointing APs at each other. All right, so this is a lineup of directional antennas, and right now from a 6 gigahertz standpoint, 9166D1, which has been out there, we're using a lot of that in warehouses. Integrated AP with directional antenna in Wi-Fi 7 is a 9176D1. Still got a lot of attraction. Higher ed, warehouses, places that you don't want to have the complexity of mounting external antennas or the regulations of mounting external antennas if you're doing 6 gigahertz. Still the good dual band wide patch antenna, the 9120AXCP. We've got a lot of 9120s running this venue. So that's still a solid solution. And we've got a lot of customers that are like, God, I don't want the complexity of 6 gigahertz yet. It's like, do Wi-Fi 6. I mean, it holds up. And then we just introduced the CW9179, which we're already seeing really good things out of this. I was really happy when we turned the Wi-Fi on this radio. It's built to handle pretty much everything we know we're going to run into. 200 feet, no problem at all. In fact, I got a video up here we'll show you. They're pulling almost 400 megabits per second.
We tested 200 feet, and we did that on the 9104 just to make sure that it works. We went through all the predominant clients. We're like, we're not saying go and deploy it at 200 feet everywhere. I mean, obviously it's a big cell, but we want to know, right? Yeah. So when we did the 9179, we were deciding what we were going to test, and I was like, it's a no-brainer. We're going to do the same thing we did before because we want to have that delta. What we found was the 9179 outperforms the 9104 in every single test we did. There's reasons for that. Some of it is we had a lot of capabilities in the 9104, and we felt like people weren't using all of them. So we went to an easier, simpler kind of configuration option, which actually, improved the performance by not having as many switches and things like that. So that was kind of key. And then the other thing about like the whole hyper-directional term, what it really is, will Wi-Fi go that far? For sure, all day, every day. In high density, it's different, right? So on the 2513s and all the predecessors before the 9104, we had these narrow antennas, but they had these side lobes. And so we were like, wow, what is going on here? So what was really happening was those side lobes, that east-west contention was killing us. So we were using features like RxSOP to knock that down, but when you turn that knob, you basically reduce your throw in every direction. So that's why we're like, hey, if you're beyond like 75 feet, you probably shouldn't do that. So what we did is we spent a bunch of time at Rocklet, it's in the Claire building, raising and lowering gear, and I think there's a video in here.
There's a video.
And we got all into band filters and all into like minimizing our side lobes, which increased our throw, which in the marketplace I think is pretty critical because it's just way cheaper to be up and out of the way than to be Swiss cheesing your arena with core drills everywhere.
All right, one of the things is it still has configurable options. Beam steering is configurable. And we have fewer. We had 2 separate beam steers and then a wide mode on the 9104. And that confused a lot of people. The other thing on the 9104 was the first hyperdirectional antenna. It was very sharp on the edge. And I had an experience with one deployment where they didn't build the roof right. And if I took 2 steps to the right, 1 meter over, I lost 6 dB. And if I took 2 steps to the right again, I picked up 6 dB and I lost 150 meg of throughput in the process of doing that. So it was very tight. This one's a little more forgiving, and that forgiveness hasn't cost us any performance like you mentioned. The other thing is we've got the back mode, so it's very easy to understand. We've got 3 modes. One of the things that people overlook on this, I've got a design right now with a convention center that's got 100 of these APs hanging. I can shut down 2/3 of those APs and go to wide mode on the rest of them and still cover that convention center when it's not busy. So it's got applications and software for sustainability. And you can read all of that directly from the dashboard or from the controller. This is implemented on both stacks, and it's actually implemented at parity on both stacks right now. I think we're still waiting the release on the dashboard.
No, it's there. We just unmasked it, so
perfect.
Now it will actually show up as a 9179. It was masked.
We did that with the release.
I will point out 2 things. The kind of bore sight / narrow versus wide was a thing where, again, if you go back in the history of HD Wi-Fi, we've been doing it since around 2008. Distance is everything when it comes to antenna selection, right? So like, it was very complicated for people to figure it out. You're like, all right, well, what's your distance? Okay, well then you need that antenna. And it's like a wide patch. Or, oh, you're further out? Okay, now you need this antenna. And there's a lot of installation errors and things that happen. But to create a fully integrated antenna that can switch beams, and so now if you're close, you just go wide. If you're far, you go narrow. Things like that.
You change the ceiling.
It's simpler. It doesn't have the configuration errors. I mean, there's a lot of reasons that this is really powerful.
You can't get the wrong AP in the wrong place.
So the same AP it can be short, it can be far, it can be indoor, it can be outdoor. I mean, it's literally a game changer.
Another thing we know, if you're running dual 5 gigahertz interfaces, clients, well, anybody can build a network. Getting clients to connect to it becomes a challenge. And what we learned several years ago, if you balance the power on those cells, even though they are just slightly offset, once everybody quits moving, they gravitate. They gravitate to the right place. They end up splitting themselves up on the cell. So a lot of thought was given to the design and the power ranges that we're running. You'll notice that we're running a low range and a high range radio on 5 gigahertz. That's to get complete isolation. Works like a champ. We run this dual 5 gigahertz everywhere we go. But that power and the balancing is key.
If you're 3 or 4 dB hotter on one side,
they will go for it.
And you need to realize that. And you kind of just lost the capacity of the AP by loading up one radio.
Yep.
So be cognizant of balancing the power.
All right. Again, there's another shot of the WLC.
Accelerometer.
Yeah, and the accelerometer giving you the angles.
So yeah, there's an accelerometer built in. We can tell you the tilt of the AP, which is super cool. We have some really cool patents on, 30 degrees above the horizon. Well, we can raise our power because we know we're pointed down, things like that. But the other thing is, from just like a installation standpoint, if you go and you tell the installer, hey, I need it at this, angle, you don't have to go and walk and validate every one. You can be like, nope, you're wrong. Or to be more fair, I'm not trying to, there's some installer out there that's going to come and tackle me. But all I'm getting at is, or something else could happen. Maybe something hit the AP or something.
You get a lift that bangs into it or something like that.
Alert on it if it changes.
Yeah, I think you could do like.
The answer is yes, we could alert.
Thanks, Jim.
You're welcome, buddy.
He's here for me all the time.
All right, enabling the accelerometer, you do have to enable it. What to expect? This is the fun part. Boy,
it's the coolest place we go. This is on the Rock Lidditz campus.
Is that a picture of a movie?
It should be a movie. Hit the button one more time.
There we go. I got it right there.
But the key that we basically went in, we took the 9104, we took the 9179, we paired them up 4 different times, and we had this huge truss with motor mounts. And at the click of a button, we could raise and lower them to different heights. And then we could do all sorts of isolation testing. And the other thing is the grid in the ceiling is etched on the floor. So we get really high resolution surveys. So like it's really hard in a 110-foot building to figure out where you are when you're looking up, but not when the grid's right on the floor. So this is our favorite place to go and figure our things out.
You forgot the best part. There was snow and ice and 20 degrees outside of that building, and we were in T-shirts inside.
Oh yeah, so that's pretty nice.
It's a huge bonus.
The 2 times we've been there to test, we did the 9104 and the 9179 there. We're both in January. So,
yes.
Yeah. Pretty nice.
Well, that's when they get a little time to do it.
We're running low on time, Jim.
We are.
We're getting hooked.
Real world data. Tell us about it, Matt. You were there.
Well, this is at Bottle Rock. My co-presenter and colleague Josh Sir got there before me and ran these surveys. And basically, narrow mode, firing across, you're at like a 65 foot wide cell, 150. This was in I think like the VIP section where all the food was. And then he had another one, next slide, where he switched it to wide mode, and you can see the difference there. It's much wider, shorter, things like that. So just the configurability of it. This part's really cool. So that arrow right there. So this is Bottle Rock just a couple weeks ago. I think Green Day's on the stage. This is what we call the soft, chewy center. That's at least what Josh calls it. And it's really, really hard to do good Wi-Fi right there. But the power of 6 gigahertz. So we went, and we have really good friends in the audio industry that let us get into the front of house sound. Let's go to the next one. And then you're going to have to play this somehow. There you go. So this is what 6 gigahertz looks like in the middle of all those people. I mean, you're ripping like 400 megs in the middle of just a sea of people in the hardest kind of place to put in AP. So 6 gigahertz rocks in high density. And we would have let you hear the sound, but Billy from Green Day said a bunch of bad words, so we had to mute it. I thought it was cool, but I figured it'd probably get me in trouble.
All right. So, Campus Gateway, it's ready to go for that. And that's all we had.